Okay, so this is part of the LibreSoc processor, the augmented CDC 6600 internal architecture, the computational unit. This corresponding video which I did, and I redrew the diagram, and it was that one. This area was a mess, so I redrew it, but this was actually wrong and I corrected it and decided to write it out again. So just a quick recap. The sequence is issue, all of the goes high first, then all of these go high, which indicate requests read 1, 2 and 3, which correspond to locking in operand 1, 2 and 3 from the register file. The acknowledgement for each of those has to come from go read 1, 2 and 3. So when read 1 goes high, this can go high, and at the same time operand 1 has to come in from the register file port 1. Likewise, request read 2 goes high. This can go high, and at the same time operand 2 comes in from port 2 of the register bus, and likewise for number 3. When all of those 3 have gone low, this AND gate will find that it goes high, but as long as the result is available as well, which is this OK signal coming in here, and as long as we are on the, as long as it's busy, which it would be at this point once that result is calculated, and this will activate all of these 3 latches, setting them to Q equals high. This is the request write phase. So by that time that result is ready, that's activated thing. So this will be firing the output, the 2 output results into these 2, and these request write signals will go high because they come from, as long as the shadow is shadow signal is also high, you'll get a request write 1 and request write 2 here. Now this one will also be high, but the inversion of the request 1 and 2, just like for this, the inversion of those will cause this, which is the reset line. When you go back on the next cycle, the reset line will be off. Now, either both go write 1 and go write 2 can be maybe asserted, or one may be resetted followed by the other one on a subsequent clock cycle. It doesn't matter which. Let's say that one of them goes in, that will reset that. It will close this latch which captures the out 1, so that the result can be put onto the bus, and request write, and that will switch that off. And let's say the next one goes a thing, and it closes that latch. That can go out on the second port, register port, write port, write bus thing, and this request 2 that will get switched off thing, but this one will still be on. Okay, all right. Now, because either of these, if either of these are enabled, that comes into here as well. Those are both off because those 2 latches are off. So that's on. That's because that was set at the same time. That is on. That is on. Right. So when one of these goes high, in any order, it doesn't matter if it's that one first, or or both simultaneously, that will trigger the reset, and doomph, the whole computation unit will be ready to receive the next immediate operand. At the same time, these will be latched out for writing. So that but notice in particular that this latch is only reset on issue, which is the next clock cycle. And that was the mistake that we made on the previous version, was that this was linked to there, which caused this to blip for a very short duration, which would not be adequate. So now let's cover that. Remember, that is off, but this one has been reset on issue, but on that cycle, that signal, this one, the go right, will of course be deasserted. This cannot be set. Issue cannot be set at the same time as go right 1 or go right 2. So this reset will be signal will be dropped on the next cycle, because the go right will be low, but the issue will be high. So this will be allowed to be reset, which will stop that reset. Yeah, you get the idea. It's already been reset. The thing, that one. Yeah, you get the idea. All right. So thank you very much.